Okay, welcome back. Who has been to my previous talk? Okay, most of you. So, as you might know, traditionally I'm more interested in writing servers than writing clients, but obviously, the reason why anybody puts up a server is mostly because they want to connect clients to it, right? So that's kind of like an important topic. So I do a lot of work with our customers to help them integrate either new clients or existing clients into these new token-based systems. And the goal of this talk is basically to give you a good guidance depending on which type of client you're writing, how you can do that. When I put this talk together, I wrote the abstract. I was pretty ambitious. I can do all the client types in 60 minutes, and then I put the slides together, and it turned out to be 45 slides for 60 minutes, so you can do the math yourself. It's going to be a lot of stuff, okay? So, but what I did is, because these 60 minutes are just the start, the beginning that you learn about what you need to learn about. So I put many links and like references to further reading material onto the slides, and I uploaded the slides already onto SpeakerDeck, so you can download the slides from there, get all the links from there, and then you get all the the further reading references. So as I said, we do a lot of customer work with help people writing or integrating those clients, and when I start working with them, or the first meeting and so on, people are often very confused. And the reason why they are confused is because it's complicated. There is so much stuff out there on the internet that give you guidance for various things, and as it turns out, just in the last months, the guidance has even changed for certain types of clients. So this talk reflects all of the new guidance that has been put out there. And the other thing is that typically you don't do OpenID Connect on your own, or on its own, or you typically don't do OAuth on its own. Typically it's the combination of both. Because only with that you get both the authentication and the session management and the API access, whereas OpenID Connect is only authentication and session management, and OAuth is only API access. So you typically combine them together. But guess what? These two standards are being maintained by two different standards bodies. So OAuth is all IETF, whereas OpenID is all in the OpenID Foundation. So you also have to string together those documents and follow the cross-references between the documents to figure out what's going on. So as I said, the objective is to filter the important information and give you the guidance for the most typical types of clients you want to write, which is server to server, web apps, native, mobile, and sparse, okay? So as I said, when you go to these websites, so what I did, I took all of their specs that they put out and tried to put them into context, and that's what it looks like. Okay, so there's a fair amount of reading material if you want to get the big picture. And there was a guy that recently counted all the pages of all the specs, and together they are twice the number of pages as a War and Peace. Okay, so it's a substantial amount of reading material. Let's put it this way. I think I read them all, and you have to also be like a little bit in the mood for that, to reading specs, as you probably, it's not happening every day, So let's get started. You probably have seen this picture before in my talks. That's the big picture. That's what we're trying to build typically, right? Front ends talk to back ends, and back ends talk to other back ends. And while I traditionally talk a lot about the back ends, this time we're going to talk about the front ends, which is browsers, native apps, and typically something like called server-to-server communication. Now, when you read those specs, they make a distinction between two fundamental types of clients, and they are called public clients and confidential clients. So a confidential client is basically, in the words of OAuth, a client that can securely store a secret. Okay, and what that basically translates to is they are typically clients which are installed on a server. right? They're running maybe in your data center. You can securely store secrets or data on these servers, or maybe they run in the data center of business partners, things like that. Public clients on the other end, these are things that run on end user devices like an iPhone or a desktop PC or a browser, and you don't have control over these things, they are outside your reach. There's also no point in storing secrets in there because where would you store them? Like probably not in the source code, right? So that's a fundamental distinction that we have to look at. And depending on what type of client you're writing, there are different approaches here. So we're going to start with confidential ones because they are the easier ones, to be honest. And then we're going to move on to public clients. So in a nutshell, right, writing a client always means this. You request a token, you use the token, right? That's what you do when you're building a client for a token-based system. But obviously, there are a lot of things happening between these two steps, which is managing the token. So let's have a look at the most simplest scenario in OAuth, which is called the client credentials flow. And that is a pure server-to-server style communication, right? So one server is calling another server. There's no direct interactive human involved. It's just two machines talking to each other, but still you want to do authentication. So the way this works in OAuth is that basically you have this thing called the authorization server. That's the term that the OAuth people use. It's a very misleading term because many people think that it has to do with user authorization. It has not. It has to do with client authorization. So in other words, this authorization server knows about all the clients in your system. It knows about all the APIs in your system. Then the client opens a connection to the so-called token endpoint. It authenticates with the token endpoint with that secret that this client can store securely. He asks for an access token for an API or for multiple APIs. And then if the authorization server says, yes, you are allowed to do that, you're getting your token. And from that point on, you can use the token. Okay? It's a very simple scenario, but a very common one, server-to-server communication. Then using that token typically means you just open an HTTP connection to an endpoint. You use the authorization header for this, and you put the word bearer on there, which is coming from another spec. It's referenced here, which basically means telling the recipient what to expect, and in this case, he's expecting an OAuth token. Okay? That can come in many shapes. There are JSON Web Tokens, there are custom token formats. OAuth doesn't mandate the token format, but the word bearer tells the recipient that is some token type that he is supposed to understand. Okay? There are other options here, like using the query string or the post body, which are more like, like alternatives if you can't use the header. Generally, recommendation is use the header because the authorization header has a special meaning in HTTP. It's reserved for transporting credentials. They often don't end up in log files, for example. And browsers treat them differently as well, and so on and so forth. So that's the typical way you do that. But once you are beyond that very basic scenario, so you got your token, you used it, it's working, now you have to write a real application. Right, and this real application now means it needs to store to manage these tokens as well. And this is typically the more interesting part because depending what type of application you're writing, you have different approaches to that. But generally speaking, you store these tokens somewhere, maybe on the server, like in memory, for example, or in a cache, or maybe it's even a distributed cache. ASP.NET has this concept of a session, for example, where you can store things. Or a database, for example, And then you have to use that token, So what you don't do is, obviously, you don't get a token for every request. You're getting a token has a certain lifetime, and then you're using this token for this lifetime. One of the response parameters coming back from the token endpoint is called expires in, and that tells you from now, this token will be valid for this number of seconds. Okay, so you have to do your own math, basically. Okay, now it's 2 o'clock. It says it expires in 3,600 seconds, so it's going to be valid for 1 hour. And now, there are two fundamental approaches how you want to manage them. One I call proactive, where you have a server-side cache system, right? So you get the token, it's valid for 60 minutes. You put it in the cache, you put the cache lifetime to 59 minutes, for example, And the next, then you start using the token, and when it's not available anymore in the cache, it was about to expire, you get a new one, and you continue working, okay? There's also like a reactive approach. That means basically you don't care about all of this lifetime management at all. You just keep using that token, and per spec, a 401 coming back from the server tells you your token is not good anymore. Okay, and then you would go back to the token service, get a new token, and resend the request. Yeah? So which approach you prefer is up to you, but you should definitely be prepared for cases where you get back a 401, so you need to have this resend logic somehow implemented. So in other words, if we look at the bigger picture is, what do clients need to do? Well, they need to request a token. So we've seen only one protocol flow in OAuth so far, and if you have read the specs or seen other talks, you know that there are more of what they call flows. Okay, so and a flow is basically like a flavor of the protocol, if you like, that is optimized for certain types of clients. Another fundamental decision that you have to take is this a headless client, or is it something that has an interactive user involved that makes things more complicated? Where do I store the token? How do I renew the token? And maybe do I require long-lived access, meaning, for example, if there is a user, do I require to access these APIs after the user has left my application, he shut down his computer? Do you need like some automated processes in the background? Keep on working, yeah? And then you use the token. That's the easy part. Okay, let's switch to the more interesting approach, which is about user-centric clients. So when you have a user involved, it's much more involved, much more complicated than just making an API call, get a token, and start that. You typically have to have a user workflow in between, right? So if you first need to send the user to the server, he needs to authenticate with the server. That might be already a complex workflow depending what you're doing. That user might be a local user, or it might go to an external identity provider, so that there are redirects involved in the browser. You might want to start a single sign-on session, or maybe you want to join a single sign-on session if this already exists. And then once all of this is done, you start making API calls on behalf of that user. And again, you start managing the token so that you make optimal use of it as long as it's valid. And once this is over, this validity time, you need to get a new token. And this should be done in a way that it's not very intrusive for your end user, right? What you want to avoid is doing like redirects in the browser or something. It should just be, it should happen in the background, so to speak, yeah? To accommodate this, OAuth created this thing called the authorization code flow. Yeah? And keep in mind, this is not an introduction to OAuth. Yeah? I will go over these things pretty quickly. We don't have the time to explain all the basics here. But the authorization code flow is call it like the mother of all flows in OAuth. That was the first one they created. And the idea is this. You are in an interactive application. You send the user to the external token system, right? You redirect the browser, for example, to this authorize endpoint. You send your parameters along. The scope list basically tells the server what resources does the client need to access. So OpenID and email means give me his subject ID and his email address, and you also want to talk to API 1, API 2. And there's this special scope here in OpenID Connect called offline access. And what this signals the server is that it should emit more things to you that allow you to manage the token lifetime without requiring user interaction, okay? The so-called refresh token, and we're going to see that in a second. So the code response type means basically once the server is done, it will come back to the client application. It will send this so-called code, okay? And the code is a one-time token, and now the client application opens the back-channel communication to the server, authenticates with the server. It's a confidential client, right? It has a client secret, sends in the code, and then the server will return back the tokens that you care about, the identity token for the front end, the access token for the API, and the refresh token for the token lifetime management, okay? That is, I think, a very common flow that you all know. This code flow has been around for many years. Mind you, OAuth is from 2012, okay? And many people thought that's by far the most secure way of doing that, right? Because you're getting the code on the front end. If an attacker would be able to attack the browser, which is the most weak, the weakest link in our chain, by stealing that code, the attacker couldn't get the tokens because he's still missing the client secret. And the client secret is stored on the server side. Yeah? So many people thought, okay, code flow is the most secure thing. Suddenly, unfortunately, attackers are also very clever. Yeah, and they find new and exciting ways to attack our system. And one problem that CodeFlow can't solve is the so-called code substitution attack. And the code substitution attack means if I can steal a code from somewhere, maybe with a network sniffer, or maybe I can trick you in logging into a malicious application, I can steal your code coming back from the server, well, the attacker can't turn that code into a token, but it can go to the legitimate application, log in on the way back, substitute the valid token with the stolen token, and thus trick the client application to use his client secret to turn that code into tokens. Okay? And now you can impersonate your victim. Yeah? So CodeFlow on its own does not have a mitigation technique for that, because there's no way to validate that the code you get back on the front channel actually belongs to the currently logged on user. Okay? So OpenID Connect came after OAuth. It came after the fact when this attack or vulnerability became public. So they designed for it. It's called the so-called hybrid flow. And let me show you that first. So when you're building an OpenID Connect-based system and you have a library which supports the hybrid flow, I would recommend using that over the pure code flow. The way hybrid flow works is this, same scenario. The only thing that has changed here is the response type. So instead of just asking for a code, you're asking for an additional identity token. And the identity token is a signed data structure, signed with the private key of the token service. So what you can do is, when you receive the identity token, you can validate the token, make sure it's valid, it's been signed by the right party. And what's inside of that identity token is a special claim called the C hash claim. And what the C hash is the hash of the code. Okay? So you first make sure the ID token is valid, and there are other things in there, nonces and things against replay protection and so on. And once the ID token is valid, you get the C hash value, you hash the code yourself, and you compare the two values together, and this way you can make sure that the code actually belongs to the identity token, which means it belongs to the currently logged on user. Okay? That's how hybrid flow protects against this problem. And my general recommendation is, don't use CodeFlow. Whatever type of client you're writing, never use CodeFlow on its own. It is vulnerable to code substitution. Okay? Hybrid flow, as I said, is one of the options if your client library supports that. So in my world, the most common client I would write using hybrid flow is ASP.NET Core-based clients. Okay? Like a web application that authenticates the user, gets the tokens, and uses the tokens. Okay? So I briefly showed this sample already in my previous talk, but basically the way this looks like is that's an ASP.NET Core application, and you can see here's the OpenID Connect library from Microsoft, and I would recommend using that if you are on ASP.NET Core. It's a really good client library. It has implemented many of the mitigation techniques that you have to, including hybrid. Okay? So you can see here the response type is not code, it's code ID token. And once you ask for code ID token, this client library knows that it needs to do all the C hashing and verifying the codes and so on and so forth. Okay? So that's very important. What I also shown this morning is that by using the built-in ASP.NET Core security features, you can also implement automatic token management, meaning you can hook into the lifetime events of the session management. Yeah, and one of these events is called validate principle, and this gets called on every incoming request. And then now the request comes in, you can look at your current access token, look at the expiration of the current access token. If the token is about to expire, you can trigger a refresh request with the token service, get a new access token, throw away the old one, store the new one in the session. And the nice effect of that is that your client code, your business application code, does not need to know anything about this. It's done automatically as part of the session management features of ASP.NET Core. Yeah? So you can see here, here's the most important line of code. That means, yes, we need to refresh, okay? And then here we're getting a new token. And you can see the other event I'm handling is called signing out. And at sign out time, when the user signs out, I'm basically getting rid of these tokens by invalidating them at the token revocation endpoint at the token service. So here is where the token gets revoked, okay? So with these two things together, you have a pretty nice client package, yeah? Web application doing authentication, getting access tokens, token management is automated at sign out time, you clean up behind you, okay? So let's run that pretty quickly. So I should run my server, I guess, that would help. It's here. Okay, so I'm logging in, Bob and Bob. Here's my consent screen. You can see I'm actually getting all these tokens. I asked for API, offline access, and all these things. I say yes, allow. And then I could call the API, and you can see here I dumped out the content of the current authentication session, and you see there's the identity token, there's the refresh token, and there's the access token. And I configured this client to have a really short access token lifetime, like 75 seconds or something. So if I talk for long enough and refresh the page, you should see that the access token is changing and that the expiration goes into the future, which shows, yes, that our lifetime management works automatically. That code is, I wrote a blog post about this, and the sample is on GitHub, and you have the link for that. So if you want to read more about how it works and how you wire it up, that's all in there. And again, you can download the slides from Speaker Deck. Okay. The world is not perfect, right? There are issues with hybrid flow as well. Not security issues, really, but the problem with hybrid flow is, and that's the reason why it's not very common, the client libraries, they are pretty complicated, right? You need to do all this crypto, right? You need to validate the RSA signature of the identity token. You need to keep track of your nonces. You need to do all other things. Then you need to do the hashing of the code and compare that with the hash claim and so on. So long story short, not all platforms have support for hybrid flow, okay? Microsoft has a really good library, as I said. It works really well. But for example, I had to do an integration for a customer recently with a PHP-based client. And guess what? There was no pre-built library for PHP that supported hybrid flow. All they supported was code flow, because code flow is much easier to implement, yeah? So that's one of the problems with hybrid flow, that the adoption is not very high, which you don't care about if you're doing ASP.NET Core, but if you do cross-platform work, you have to make sure that the platforms you're trying to use have support for that. Yeah? The other thing, which is a bit funny sometimes or not, depending on how you see it, hybrid flow was invented before this thing called GDPR. So in hybrid flow, there is a mandatory claim that you can't strip, and that's the user ID of the current user, because you need that for linking the identities between the various hops. Which means, you are transmitting a token over the front channel of a browser, and inside of that token there is a unique identifier for the user. Now, the recommendation is that this unique identifier should be just a random number, right? Some internal identifier, but not everybody listens to my recommendations, yeah? And sometimes people use email addresses, for example, as subject IDs, and then suddenly, depending on your GDPR consultant, he flags this because you are leaking information on the browser channel about the user, which is, a byproduct of this mechanism, which you can mitigate by not using email addresses, I guess, and using real user IDs, but that's just the way it is, and you might run into that if you're using this approach. Okay, let's switch our focus to public clients and see what's happening there and how they involved, and maybe we'll find afterwards a solution to solving our hybrid flow problem as well. So in public clients, as I said, they are deployed to on client devices, in browsers, and so on. And the way you treat them is slightly different. So with confidential clients, you typically have a one-to-one relationship between the client ID and the instance of the software that you're using, right? You have your app 1, app 2, app 3, they are all installed on the server. Each of them have unique client secrets, so that's how you identify these clients. With public clients, that's typically not how it works, right? Because you are writing a client, let's say an iOS client, you give it a client ID, you deploy it to the App Store, and then 1 million people download it, they all share the same client ID. right? Because that's just the way it is. There's nothing bad about this, yeah? I'm just making you aware of that suddenly you can't identify instances of your software anymore, but only types of software. Depending on your security requirements, there is something called dynamic client registration, and the idea is, especially for native apps, that you're shipping your app to the App Store, for example, using a bootstrap client ID. And then the first time the user runs this, the user authenticates with your backend system, and then the backend system issues a unique new client ID down to the client, and maybe also a client secret, right? Because it's now bound to the instance, and that's how you can effectively turn a public client into a confidential client. So that's, you know, my bank does that, for example, yeah. It's also very common, let's say you have some commercial back-end software, maybe SAP, something like this, and they ship their client software via the App Store. Then on the first time you run the client software, they pair with the back-end, and suddenly you become a unique client, for example. But that's something you have to implement yourself. So let's have a look at native clients first. So native clients, the good thing about native clients is that there is a really good document to read. Yeah, one of the many documents that the IETF put out. One is called OAuth 2.0 for native applications. Yeah? And the first confusion is that people say like, yeah, but I'm not doing OAuth, I'm doing OpenID Connect. Yes, but this document was written by the IETF. And the IETF owns OAuth, so they can't use the word OpenID Connect in the title. But guess what? All of the reference implementations of this spec, they use OpenID Connect and not OAuth. And the sample code is hosted on the GitHub organization of the OpenID Foundation and not on IETF. So it's a bit silly. Yeah? It's an artificial separation of two things that really closely belong together, but makes your or our life harder to find the right pieces of information, really. Yeah? So, but nevertheless, ignore the title. Yeah? It's for native applications. And it's not a protocol, it's what they call a best current practice. Yeah? Best current practices are basically documents that they put on top of the protocol. So what they do is they tell you what are their best practices for using this protocol in that specific situation. Yeah? So it's actually a really good read because it's very practical. It specifically talks about features of iOS and Android and Windows and macOS and so on, and how you would do these things. So it's very, very good to read. One anti-pattern they point out is native login dialogues. Yeah, so, for many, many years, native developers, the intuitive thing to do for authentication is they write a dialog and drop over the username field and the password field, right, and do their own thing. So OAuth has a flow for that. It's called the resource owner password flow. And the idea is that you collect the name and the password in the native dialog. You send that to the token service. You get back a token. Then you store that token, hopefully securely. And then you start using this token and throw away the original password. Yeah? In theory, that's good, but I always get suspicious when I see these native login dialogues, because now you have to rely on the fact that this developer did the right thing. Did he really throw away my password? Did he really store that token securely, right? And one good exercise, if you want to do that, is, when you back up your iPhone, you do two backups. One is the application backup and one is the keychain backup. So in theory, in the application backup, there should be only the apps that you installed, and in the keychain backup should be all sensitive data, like your tokens and your passwords and so on. So what I did is I did this backup and only installed the application backup or restored the application backup on my new phone. And in theory, I should be locked out from all apps on the phone, right? What do you think happened? I was logged into many, many apps, right? And what does that mean? That the developer just stored the token or the password just in the application directory. They didn't even use the secure data storage features of the platform they're on, okay? And that's just a byproduct of, giving all responsibility to the client developer. So you shouldn't do that if you can. And, that's always a bit tricky to explain to your non-technical manager. But what you really should do is you should use a server-side rendered login page, right? Instead of building your own native one, you open the browser, you go to your login page on your token server. Everything exists already, right? Your name and password and your external logins and your logging and your auditing and all the things that you build already for your login page, and you just reuse that from the native client, okay? So let me show you a quick demo of that as well, how that looks like. So here is an iOS device, right? So when I click login, it uses a special API from Apple to open an instance of the system browser inside your application. And why do you want to have the system browser? Well, because you want to reuse the cookie container on your mobile phone, right? So let's say, for example, this application allows Google logins and you're already logged on to Google on your phone. You can get single sign-on now in your native application, yeah? And I think that's a big usability improvement. So when I click the login button, and I use this special Apple API, then Apple will insert a little screen here saying, hey, be careful, you are now authenticating. Regardless of what the app just told you you're about to do, you are authenticating, because that's the only reason why you would invoke this API, okay? So they show you the name of the app, they show you the name of the server you're gonna authenticate to, and there's a chance for you to say like, that's weird, why does Angry Birds need to authenticate me, yeah? So, and then it goes to a login page that you can style in any way you want. In this case, it's just our standard login page in Identity Server. And you can see this page allows Google logins. Now, fingers crossed, have you heard that Google will shut down their login endpoint? Actually, yesterday was the planned date where they shut down the old login endpoint. So when you're using Microsoft's Google library, there's a chance it'll stop working in the next couple of days. Yeah? I'm still using that, so fingers crossed. Yeah, I'm still logged in, okay? So I got single sign-on with Google. Now this is the consent screen that is the application is showing. I say yes, I'm okay with that. And now we transport the tokens back into the native device. The access token, refresh token, then I would store the refresh token on the secure data storage platform like Keychain, for example, and from that point on I can do my token management automatically and renew my lifetime, right? So when I call an API, that's working. I can refresh the token, that's working as well. And I guess when I go to the token service, come on, and revoke the token, like click here, log in with the same account. Here's my application. I'm going to revoke the token, so next time this application tries to refresh it, it will fail. Okay? So how does that work? Before I show you how it works, let me show you another example of that. For example, GitHub Desktop. Yeah, so GitHub Desktop is a desktop application. It's written in Electron, which is native enough for me. So the idea is when you want to connect GitHub Desktop to your GitHub account, the chances are quite high that you have an existing logon session already in your browser with GitHub. So you can say sign in using the browser. It goes to GitHub. It comes back to you. And I'm logged in. Okay, which I think is a nice user experience and much, much nicer than now having to type in my GitHub password into a native dialog, than to two-factor authentication, waiting for the SMS to come in, right, and so on and so forth. Yeah? So native dialogues, they are a thing of the 90s. Okay, so the way this works is, well, they're using code flow, yeah? Response type is code. The only thing that's different here is you see that typically what you do is you register a so-called custom URI scheme on the operating system that the operating system knows, yeah, when the browser is calling this last URL, it will transfer control back to the client application. Okay, and then you get the code, and then you can make the call over the back channel and get your tokens, right? So now, how do they protect against code substitution? Well, there's a subtle thing here happening. You see here, there's this thing called the code challenge. So you see the code challenge. So the thing you do is you create something called a code verifier, which is just a random number. Then you hash that random number, and you send that hashed number as the code challenge to your server. So what the server now will do is it will associate the code challenge with the code, okay? And on the back channel communication, you're sending the clear text random number, which is called the code verifier. And then on the server side, the server will take the code verifier, hash it, and compare it with the hashed verifier you send in on the front channel. And only if they both match, you know that you're actually handing in the right code. Okay? That's another way to mitigate the code substitution attack. And this is called PKCE, proof key for code exchange. And it solves the exact same problem as a hybrid flow, but it's much easier to implement because the client doesn't need to do anything beyond creating a random number, hashing it, and sending it to the server, and the server is doing all of the validation. Okay? So in the long term, my prediction will be that most people will just implement PKCE because it's so easy to implement, and that will solve the code substitution problem for all client platforms. Okay? Good. Again, after that, you need to do token management, and you store it somewhere. Some applications, like when you're using the keychain, you can put additional biometrics on top of it. So my banking app, for example, it stores the refresh token in the keychain, and then I have to use Face ID or Touch ID to unlock that item again, and then they can get the refresh token, they can get an access token from there, and so on. Okay. Client libraries that implement all of this for you, well, there are two reference implementations for that. One is for iOS, written in Objective-C. One is for Android, written in Java. And that's a library written by me. It's in C#. It's using, it's a so-called .NET standard library, so it runs on multiple platforms as well. And, maybe that's more up your street than using Objective-C, for example. Okay, the big elephant in the room is browser-based applications. And they are traditionally the hardest to secure type of application because they run in a really hostile environment. Yeah, it's called a browser. Yeah? And the browser, think of the browser as a shared execution runtime where multiple applications run at the same time in multiple tabs, and one of them might be malicious, the other one might be trusted, and but they're sharing basically the same browser. And you know that there are attacks to browser-based applications which only exist because of that fact, and they start with the word cross, right? And that basically means you are making calls across a trust boundary. A less trusted application might inject code into your more trusted application, yeah? For example, that's called cross-site scripting, right? Or you might leak data across boundaries, for example, cookies or basic authentication headers or Windows authentication headers even, and that's called cross-site request forgery. Now, these are browser-specific problems that are hard to solve, okay? Actually, I wrote a blog post about this recently, and I went back to the old OAuth archives, yeah, to see what was the motivation and thinking when they started working on these specs, yeah? And there was a long discussion. Going on, and the conclusion was this. Yeah? It's very hard to secure them. So we've been talking to the IETF for a long time and saying, like, wouldn't it be great if there would be a comparable spec out there or a best current practice, just like the OAuth for native apps, like something like OAuth for browser-based apps, where you bring all the smart people together and they once and for all write a guidance document. What are your options for sparse? What are the trade-offs? What's the threat model? What do you have to think about? Okay? And they were kind of avoiding that discussion for a long time because it opens up a whole can of worms if you do that, as it turns out. Yeah? Just to give you some history to understand where we are today, traditionally, when we started building sparse or browser-based applications, right, they were actually just old-school web applications with extra JavaScript, right? We sprinkled some Ajax here and there to make them more responsive and more fun to use, right? But people were still using cookies to secure these API or Ajax calls. Now, cookies have one fundamental problem. It's called cross-site request forgery, right? That basically a browser can leak cookies across domains, meaning you're going first to your good app, log in, get a cookie, you get to your bad app, and this bad app makes a call to the good app, and the browser will send the cookie along across domains, and then the bad app can impersonate the current user. Yeah, obviously that there were mitigation techniques for that. They are well understood. They are called anti-forgery protection. Yeah. If you're an MVC developer, you all know them, right? A validate anti-forgery token and the anti-forgery token hidden field and so on. But there was no common guidance for APIs. So I did many code reviews in the past where people called APIs from the browser, used the cookie to secure them, but they didn't protect the cookies against cross-site request forgery. Well, because mostly, to be honest, and that's a bit sad, is because Microsoft never put these things into the standard templates. Right? Everybody knows about the MVC way of doing it. Not that many people know what they do, what they have to do for APIs. So the IETF in 2011 or whenever, 2010 maybe, started to say, okay, can't we use OAuth to get rid of cookies, right? So they started working on OAuth 2 by the time, and there was this new flow they wanted to invent called the Implicit Flow that makes it easier to write sparse. And as you can see, in 2011, it wasn't very clear to everyone why you would ever write a JavaScript-based application. Okay, that's a nice screenshot from the IETF email archives. Yeah, he did Google for it. It didn't help. So the one limitation we had in 2011 was there was no CORS, yeah? No cross-domain AJAX requests were possible. So, you know, you might say like, why can't we just use CodeFlow just as we use for all the other types of clients, yeah? Well, because CodeFlow requires the back-channel communication, which means cross-domain AJAX calls. This didn't work, right? CORS didn't exist by the time, so they came up with a very, very simplistic approach where basically, you know, the SPA makes a request to the server, and the tokens come back directly on the URL. Yeah? That is still today the official guidance how you should write SPAs. And if you're doing that, don't feel bad about it. It's not that you're doing something wrong. It's just that now it's 2019, right? And we have solved the problem of cross-domain AJAX, and we have CORS. So maybe we shouldn't do this anymore because now we can make back-channel calls from JavaScript, and we don't have to expose our tokens anymore on URLs. Yeah? What's bad about URLs? Well, they can leak. That's one problem. You specifically have to use the hash fragment here, otherwise browsers leak them, for example, on referrer headers and other places. They end up in your browser history, for example. Again, you can write some JavaScript code to remove them from there. But you have to do a couple of things, yeah, to make this as good as possible. And still, there are implementation flaws in many implementations. And still, we are relying on all the browsers doing the right thing with regards to the hash fragment, for example. So if they ever change that behavior, we have a big problem. Yeah? So in other words, long story short, the IETF announced, so to speak, that they're going to deprecate the implicit flow in the sense of it's not what you would use anymore today. Okay? And in my opinion, that's a good thing, because you have one flow less to learn now. Because what they want to do is they want to do CodeFlow with PKCE. Okay? And it turns out that if you look at that, server-side web apps could do CodeFlow with PKCE, native apps can do CodeFlow with PKCE, JavaScript apps can do CodeFlow with PKCE. So basically, you only have to learn one flow in your company for all of your client types, yeah, which is actually really good because that was very confusing before. And that's the current, guidance, so to speak. As I said, if you have a current application using implicit flow, it's not that you are vulnerable to something new. It's just that, we now have better things, or better ways to do the same thing. To be honest with you, the whole discussion of implicit versus code, yes, that was interesting, and code is definitely better than implicit. But there's another thing that is specific to browser-based applications, which is not solved by just changing the flow, and that's token management, or more specifically, token storage. Yeah? So in JavaScript, there is no secure data storage. Yeah? Regardless what you use, session store, local store, IndexedDB, whatever, they are all accessible by JavaScript. So if you have a cross-site scripting attack in your application, anybody can just download the contents of your storage, and that would mean tokens, right? And then they could use these tokens to call your APIs directly. The other thing is, yeah, when people say like, yeah, let's do code flow, that also implies you could do refresh tokens, right? Refresh tokens are long-lived often, yeah? So that makes it even worse because now you have refresh tokens in the browser that are potentially long-lived, that don't have a client secret, and if they get stolen, an attacker can potentially get new tokens for an extended lifetime, yeah? So the thing you really have to protect against, in my opinion, is not OAuth and these things, it's cross-site scripting, okay? And it turns out that is not easy. First of all, you should be on the latest versions of the front-end frameworks, right? Like the latest versions of Angular and the latest versions of React, they are pretty good to give you good cross-site scripting protection out of the box. At least for the code that is produced by the framework vendors. Now you download some shady extension from NPM, you never know what they're doing, right? And both React and both Angular have escape hatches, yeah? So something like an API called unsafe write to DOM, yeah? And what does unsafe mean? Well, it's unsafe, yeah? And some of them, you know, to make their life easier, they use these low-level APIs, and obviously when they get injections in there, you suddenly get non-sanitized output in the DOM, which can lead to cross-site scripting, right? So be careful with that. The other thing is content security policy. So how many people in the room write JavaScript applications? How many of you use content security policy? Yes, that is depressing, yeah? It's, you know, CSP was specifically designed to mitigate cross-site scripting attacks, okay? But not many people are using it, and I'm not saying you are lazy. The reason is it's hard. It's hard to use, yeah? It's very, very hard to take an existing application and add CSP to it because it's so restrictive that it most probably will break your application, yeah? It's much, much easier that when you're writing a new application that the first thing you do is you create a CSP policy and then you write your code to be CSP compatible and not make your CSP compatible with your code, right? That's much better. I really thought CSP is working really well, and then I spoke to a guy from the OWASP team recently, and he pointed me to this video here on YouTube, and it's from Google researchers, and what they did is they spidered the internet, right? They have the technology to do that, I think, and they found only 1.6 million CSPs on the internet from all the websites they inspected, which is not a lot, right? And to make it even worse, because they were also loosely defined, they were able to break more than 90% of them, okay? And the golden rule is, when you watch the video, the longer your CSP gets, the more probably it's broken, okay? It should be a very concise, small one. People, for example, whitelist CDNs in their CSP, right? Don't do that, right? I mean, on CDNs, there was all kinds of stuff. Do you trust every single thing on a CDN? They found out if there's a single JSON-P endpoint on the CDN, you can bypass the whitelist because you can abuse that whitelisted endpoint to load other JavaScript from, you know, other locations, for example. So watch this video. It's very enlightening, especially because they give you good tips how to lock down your CSP as well, okay? What? The link is dead? Then search on YouTube for Make CSP Great Again. Make CSP Great Again. Yes, these are the talk titles we have to, your fault. The other thing you might have heard of is called token binding. Token binding is also a very promising technology to basically bind your tokens to the browser, meaning if somebody can steal the token from the browser, they can't use it because you need something in the browser which is not accessible by JavaScript, and if you remove the token, this thing is missing, it doesn't work. They went a couple of years to standardize this thing. It's now RFCs, it's all good, and in the last moment, Google said, we're not implementing it. We don't think this feature is useful. So they actually had it in Chrome and they removed the code, and that's the thread on their issue tracker that talks about this over 20 or 30 pages. All kinds of people had tried to weigh in. It's gone from Chrome, and to be honest, if it's not in Chrome, it's pretty useless, right? I mean, there's one big browser missing that feature, then you can't rely on it, yeah? We updated our client library, OIDC Client.js, to support code flow now. And to be honest, if you're using that client library, all you need to do to change from the old implicit flow to the new code flow is change this response type property to code. That's it. Okay, and then you're getting all the new code flow stuff for free, which doesn't save you from saving yourself against JavaScript. Cross-site scripting, right? So that's still an unsolved problem, in the sense of that you can do it 100% secure. I can show you the SPA sample that we use. Typically, you see, basically the idea is you have an HTML file, you're loading this OIDC Client.js, you're setting all your parameters like the authority and the client ID and the response type is code and your scopes and all these things. And then to basically start the token request, you call sign in redirect, and to log out, you call sign out redirect. So with a good JavaScript-based client library, you can remove all of that complexity from the business code. So when I run that, it won't be very exciting, but I can press a login button. So I can log in, right? I log in. You see we're using, we're using CodeFlow and PKCE, so it supports PKCE as well. And we are back in the client. Here's your user object. Here are your tokens and so on. And basically what this library will also do is in the background refresh the token, not using a refresh token, but using something called silent renewal, which basically binds the tokens to the session lifetime, which I think is a bit more secure than having refresh tokens unbound from the session. And then I can call APIs, I guess, and log out again, what you would expect. So that's, nothing really has changed for your application code, but if you want to follow the latest guidance, then switch to CodeFlow. Another thing has come up recently that I want to make you aware of. It's called SameSite Cookies. So you maybe remember that when I started with the history thing here, I said the starting point was that many people use cookies to secure their APIs, but browsers send cookies cross-domain, and that leads to cross-site request forgery. And just recently, the W3C added this to the cookie spec. It's called SameSite Cookies, and when you're issuing a cookie, you can append the SameSite flag and telling the browser how it's supposed to send the cookie. And what it essentially means is the browser will only send the cookie now if it's been originated from a page that belongs to the same origin where it came from in the first place, effectively mitigating cross-site request forgery. You might think, like, why didn't they do that 5 years ago? Or 10 years even, right? Wouldn't that have been the most obvious thing to implement? And I guess, I don't know why they didn't do it. Maybe nobody thought about it, So in theory, if same-site cookies would be a reality, our cookies would be much more safe, okay? And when you look at can I use, all of the recent modern browsers support it. The only issue I have a little bit is that the very last version before the most recent one sometimes doesn't support it, right? So if you know users, right? They're not often, not always on the latest and greatest version. So for example, if they are still on iOS 11, they are vulnerable, right? If they are on an earlier version of Safari, they are vulnerable and so on. So I think it's a little bit too early to just put all your baskets into the same-site cookie, all your eggs into the same-site cookie basket, But I think if this keeps on going, this gives us another really nice, defense in depth mechanism. So I have a couple of customers that said, like, I understand. You have to throw humongous amounts of JavaScript at my front end to make it secure, right? You have to write use a client library and do the token management and protect against cross-site scripting and blah, 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 blah. So they come up with another, that's not, by the way, not my name here, the BFF architecture. It stands for back end for front end. And the idea is that basically what you're doing is you're doing all of your token business on the back end, like with ASP.NET Core, for example, with OpenID Connect. You store the tokens server side, you manage the lifetime of the tokens on the server, and whenever the front end needs to call an API, it calls that server in the same site, and you're either using SameSite Cookies or maybe SameSite Cookies plus empty forgery, yeah, to make them more secure. And then, you know, the connection between the front end and the back end is secured by cookies. And whenever you want to call, you know, like cross-site or, you know, like cross-origin APIs, you proxy them across your backend. The backend attaches the access token to it, and it becomes a pure server-to-server communication. Yeah, I mean, that is an alternative. Don't think that this saves you from getting rid of your cross-site scripting, right? I mean, it's still the same problem. If somebody can inject script in your front end, it can make them call the backend, and the backend will happily attach the token to it and then call other services, right? I mean, it's not a solution for cross-site scripting, but it's a different approach to building these types of applications if you think the other one is too much black magic. Okay? I've written a blog post about that as well. I can quickly show you the sample because we have 5 more minutes. So that's this guy. So you see basically the host here, the host basically does all of the OpenID Connect and OAuth business on the server side, just like I showed you the very first ASP.NET Core application. But then it renders out a SPA, okay? And then you can implement your own APIs here, for example, if you want to have some APIs, right, that are working for your SPA, for example. You can implement them here. That's why it's called backend for front end, right? And they are really best friends now. So I log in. Okay. Oops. Oh. Let's see. Let's run it again. Hello? Let's try it again. Okay. Yeah? So now we come back, we render the SPA out. The SPA itself doesn't store any tokens. It's just using a cookie. The cookie is HTTP only, so it's protected from cross-site scripting. The cookie is same site as well. Yeah, so we can have a look at our cookies here. So here's my BFF cookie. You can see it's HTTP only, and it's using SameSite strict even. So there were 2 settings in SameSite, lax and strict. Lax allows GET requests with cross-domain, and strict allows no cross-domain request whatsoever. So that's working as well. And now I can call my local API, for example, you know, that just uses the server-side identity, sends me back some data. And if you are, you know, now having to call backend APIs, then there are 2 approaches here. One is that you're building, you know, like a front-end API that then calls the backend services, or you proxy maybe through the front end to your backend. There's a pretty handy open source project which makes this proxying pretty nice. It's called ProxyKit, and what it is basically, it's a reverse proxy as middleware. So if you need to ever have the need of reverse proxying calls from the front end to the back end, instead of replicating all the APIs, you can put in ProxyKit here. Whenever something comes in on /API, it forwards it to the back end, and you see it does that by attaching the access token that is stored on the server side as well. Yeah. So when I run my API here, which is the backend API, and then I'm making an API call from the front end, you see it first goes to my BFF, right? The BFF proxies it to the back end, attaches the token, and that's working as well. Okay? So I'm not saying one is better than the other. Both have the cross-site scripting problem, yeah? But they are different, yeah? And some people prefer one approach over the other, and some people prefer the other approach over that. And all I'm giving you here are 2 options, really, yeah? But still, public enemy number 1 will be cross-site scripting, and that's definitely something you have to look into when you're building SPAs. Look into CSP, especially look into CSP. I think that's my recommendation number 1, to try to make this work for you. Here are some more links. for you that you can read after whenever you want. That's it. I have a limited amount of stickers here. If anybody wants stickers, there are not enough for everyone. And with that, thank you for your time, and I hope you enjoyed the rest, or you enjoy the rest of the conference. Thank you.